Hello and welcome to today's Tech Talk on optimization modeling with AMPL, Nextmv, and Streamlit. My name is Haley, and I'm part of the Nextmv team here today. I will be your MC, but your presenters extraordinaires today will be Philippe from AMPL and Nicole from Nextmv. They'll be covering quite a bit over the next 28 minutes here, beginning with a quick primer and orientation, and then diving right into the good stuff, a speed run and demo. We will be leaving time for Q&A at the end, so we encourage you to use the Q&A feature at the bottom of your screen to drop in your questions, or you're also welcome to use the chat off to the side. We recommend that you keep an eye on that host and panelists versus everyone toggle in the chat, just to make sure that your question or comment gets to the right audience. There are several folks from the AMPL and Nextmv teams who are also tuned in today to support any discussion that's happening, so feel free to discuss as you see fit there. So with that, I'm going to disappear into the Zoom backstage and let Nicole and Philippe take it away.
Thanks for the intro, Haley. So today we'll be exploring three technologies: AMPL, Nextmv, and Streamlit. AMPL is an established high-level language for expressing complex optimization models, and Philippe is going to dive more into that in a moment. Nextmv is a decision ops platform that accelerates decision model development, and I will be diving more into that in a moment as well. And Streamlit is a popular open source framework for building web applications. When you use these three technologies together, you unlock the ability to build and deploy custom models on production-ready infrastructure and perform experiments and collaborate cross-team on results, and visualize and interact with these custom models through an accessible UI. Here is one way that you can integrate these three technologies together to achieve the outcomes that I just described. What you can see here on the left is you have a logistics operator that is interacting directly with a Streamlit application. That Streamlit application is functioning as the UI and as the client for communicating with the Nextmv platform. So that Streamlit application is generating inputs and receiving results from Nextmv, and it's communicating with the Nextmv platform. Over on the right, you have the developer who is interacting with the Nextmv platform directly. So they're pushing up their AMPL model built on top of a high solver or whatever model you have, and generating custom endpoints that are now exposed for that Streamlit application to communicate with. So this interaction diagram is how we can incorporate those three technologies in a way for the developer to be able to expose their work to the logistics operator. And so this particular interaction diagram is what Philippe will be walking through in more detail with an example. To set up Philippe's walkthrough, we like to put demos in the context of a hypothetical business that we call the farm share company. The farm share company is a consumer delivery service for farm-based goods, and business is booming. So we're growing to more customers in more cities, and so we want to add additional distribution centers so that we can satisfy that demand. So the two questions that we're going to ask ourselves today: one, where should we locate these new distribution centers given that demand and our constraints? And two, how do we get stakeholder buy-in in the process? A lot of optimization problems typically will focus on that first question of where should we locate these new facilities given our demand and constraints? But we'll be using Streamlit to really deliver on that second question of getting stakeholder buy-in. With that, I will turn it over to Philippe to do a speedrun demo.
Thank you all for being here, and thank you for the invite to be part of this talk. Here I'm going to start by showing that now there are some AMPL apps available on the Nextmv marketplace. So in this case, you can even just come here and pick the facility location app, solve this problem, clone it, and in my case, I already have it cloned. And once you have it cloned, you get access to an app that is deployed on Nextmv platform and gives you this nice REST API for you to interact with. But one issue for this type of problems, when you we have decision makers that are not technical and they want to interact with your optimization model, you need to put a nice UI on top of it. And for that, there is Streamlit. In here is where we have a collection of apps for many applications. One of them is a stochastic facility location, which addresses this problem that we are focusing on today. In this app and in a few others, there is a place where you can configure how to connect to Nextmv, so that you might have multiple decision makers making decisions simultaneously, and you want them to be able to solve these problems that might sometimes be fairly big in isolated environments. So you just need to configure here using your Nextmv API key, the app ID, and the version of the app that you want to use. And once that is configured, it will be solving here on Nextmv. Now let's look at the app. For this problem, you want to expand, you might not be sure about the state. So one of the first things that we allow is picking the state where you want to open your facilities. Then decision maker might be considering different locations, and you might, let's say you send them a static report, but they say, okay, but what if we built in this other city? With Streamlit, you can provide them with an interactive report that they can just come here and add whatever city they think is necessary. And the same applies for customers. Adding or removing customers, you just use these inputs to control that. In this map, you can visualize the locations. The green points are possible locations for facilities. The red dots are locations for customers. Then one of the things that we need to take in consideration is the distribution cost. So the distance between the customers and the facilities. In this case, we are just using the direct distance between them. We could really use the exact distance, for instance, using Google Maps API to calculate routes. Or in this case, we just simplify that direct distance multiplied by some constant. In this case, let's keep it at 1. This is in terms of costs for distribution. Then there are other parameters that also needs to be configured. For instance, the different facilities in different cities, there might be different capacities that you can consider. Here you can adjust the capacities. And there are also different costs for opening these different facilities. You can just edit the fields here. Then there is the part where there is usually, in this part there is often some certainty. In this part there is usually a lot of uncertainty. So it is really hard to predict the exact demands from these different customers in different cities. So one thing that you might be able to predict with some confidence are ranges, like the minimum expected demand, maximum expected demand. And then you can generate a set of scenarios within these ranges and solve a stochastic optimization problem with all these scenarios taken in consideration. And the problem is already solved using eyes on Nextmv platform. It could also be solved using Groby. Here are the two facilities that were picked by the solver. In this case, we are just really solving a stochastic optimization problem using that app. Another thing that people sometimes do is, instead of just solving one stochastic optimization problem, sometimes it is hard to solve a stochastic optimization problem. You might need to decompose it. It might result in numerical issues. So a different approach is to solve each scenario to optimality and then to aggregate the solutions and make a decision based on that. Let's see here on Nextmv. The run's happening. Okay, and it is done. So how much time it took to solve to optimality for each scenario. And here we have the solutions. And in this case, we are just looking at average number of times each city was picked in the optimal solution. And we could, from this, eventually conclude the same as the stochastic optimization solution. The stochastic optimization approach is the scientific approach. This other approach is an alternative in case it is like too complex to really do it via regular stochastic optimization. But often people end up doing this in practice. At the end of this app, like at the end of several others, we have always a link to the source code on GitHub that takes you here. And in here, you have the backend that is also running on Nextmv, the model, and you have the front end. And in the README, you can also see how to install Streamlit, how to get it to run, and also how to deploy the backend to Nextmv. And in here, I just want to highlight the main thing is how easy it is to produce a nice UI to put on top of your optimization applications using Streamlit. So you just need this, import Streamlit as ST. And then in your app, in order to get something visual in your app, you just have lines like this. st.header stochastic facility location is what results in this. Then this piece of markdown is this block that you see here. Then you see this expander for mixed integer programming model with some markdown inside. That's what you see here. And in terms of interactive inputs, you have here where to pick the state. So let's scroll down a little. So this is how we pick the states. We just need one line like this. As this select box, we pass the list of states, and as a return, we receive the name of the state. For the facility locations is this. So the multi-select that receives a list of possible cities and returns a list of cities selected. The cities for the customers, another multi-select. So when I say multi-select is this type of inputs that you see here. And just another thing, how we do it, how we display that map is just this. We just need to pass pandas data frame with the latitude and longitude of these coordinates, the color that we want them, and the sizes. And that will automatically show up visually in your Streamlit app. So it becomes really easy to do the UI. Now, a little about what is happening in the backend. So in the backend, we are solving an optimization problem using AMPL. So a stochastic facility location problem. Here we have a description using mathematical notation. But one really nice thing about AMPL is that it is more readable than mathematical notation because you can use nice names. So you have a set of facilities, you have a set of customers. There are shipping costs between facilities and to customers. In this case, I'm just solving the deterministic version, just one scenario. There are opening costs for the facilities. There are customer demands and facility capacities. Then there are variables that are going to control how much you ship from each facility to each customer, and the binary variables that control whether or not you open a facility. These binary variables, they are the stage one decisions. That's what you always fix up front. So you make that decision in its run. Then the way you distribute the products to customers is going to depend on the concrete demands that you are not able to predict exactly up front. The objective, minimize the total cost. So we have this sum for all facilities, for all customers, the shipping cost times the amount that we shipped from each facility to each customer, plus the fixed costs for all facilities, the opening cost times the binary variable that will be 1 if the facility is open. In terms of constraints, we need to satisfy customer demand, the sum for each customer, the sum for of the amount that we ship from each facility needs to be equal to the demand for that customer. We need to respect also the facility capacity. So for each capacity, the amount to ship to all customers must be less than the facility capacity times the binary variable that will be 1 if the facility is open. And here we just have the linking constraints for whenever there is shipment between a facility and a customer, the facility needs to be open. So forcing this variable to be 1. Here we have another model, but now the stochastic version. And AMPL makes it like really easy to move from one to another because essentially you just add another set for the scenarios. And now you index over scenarios what is uncertain. In this model in particular, we also allow uncertainty across the for the shipping costs. So there might be uncertainty there. In this app in particular, we are only considering uncertainty in the customer demand. And for instance, let's look at the objective. The main thing that changes in the objective is that we are summing across all facilities, all customers, and also all scenarios, taking into consideration the probability of the scenario, times the shipping cost, times the amount shipped, plus the first stage decisions for all facilities, the opening cost times the binary variable that will be 1 if the facility is open. And then similar for the remaining constraints, again, adding just the additional indexing set. And that's it. So one particular thing about these very well documented models is that they were not written by me. They were written by my colleague here that is very good at writing AMPL models. So write an AMPL model for facility location. That model that you see there. Then I asked, okay, give me better names. He failed the first time. I wanted more descriptive names, and he gave me a better model with more readable names. And then, okay, I also want a stochastic version of it, and he gave me the stochastic version of it. So all the models that you see there and very well documented, they were not written by me. They were written here by my colleague. But in fact, what is running in that app available on the marketplace is stochastic facility location using vendor decomposition. It allows us to reduce the problem size substantially and also to go to way bigger scales and taking better advantage, for instance, of eyes, because these problems, they can really explode in size. In these examples, I was showing just a small number of scenarios. In practice, you should be considering thousands of scenarios. So it becomes like really fundamental to decompose or really solve the individual using the individual scenario approach. Okay, and that's it. Thank you.
Thanks, Philippe. All right, so what does this mean for the decision science space? This was a really great demo that showed how a developer can create a new facility location planning model, really any model. That developer can also create a Streamlit UI and can interact with that UI and with the model using Nextmv. And what this unlocks is the ability for developers and operators to collaborate together on model outputs and have a better understanding of the decisions that are happening. And so both the operator and the developer can get to a shared understanding of that model faster. Put another way, the conversation with project stakeholders starts to become a lot more efficient. An operator or manager can interact with the developer's decision model in a more intuitive way, rather than a developer spending time piecing together screenshots or static dashboards, making slide decks. They can use Streamlit, AMPL, and Nextmv to have a better shared understanding of what's happening. So this is the type of collaboration that Philippe demonstrated to you today. So just as a reminder, the Streamlit application is functioning as the UI and the client to Nextmv, and the developer is interacting with Nextmv to push up their custom model. But what we're looking to do is to streamline the Streamlit experience. We were really inspired by the work that Philippe did and his team at AMPL to integrate these three technologies. And so we want to make it easier to work with Streamlit on the Nextmv platform. And so this is an alternative way of integrating these three technologies. And I'm going to give you a sneak peek of these pre-release features in a moment. So in this world, Streamlit is embedded, Streamlit applications are embedded directly in the Nextmv console. And what this allows you to do is do input generation the way that Philippe just showed, directly from the Nextmv console using your custom application, your custom Streamlit application, and you can do more formalized orchestration that way. And this is really valuable for a few different reasons. First, it gives you a unified experience, so less context switching between Streamlit and Nextmv. better auditing, so you can know what was created and run when, and you have access to modify people's roles on the team. Input and output exploration, so you not just experiment viz, and you don't need to remember your Streamlit app settings for a given run. It's all captured in the Nextmv console, and we handle all the security things behind it. So where this is headed is in the direction of these 4 areas. So first, persona views. What we'd like to unlock is the ability for you to create custom views depending on the role of the person on your team. So for example, an operator might see a different view in the Nextmv console than a developer or an admin or a viewer. Input generation. So this was really inspiring from what Philippe did, where you can have these select boxes to construct your input to scenario testing without having to come to the table with your own JSON file already created or your own CSV. So that's a big area that we've invested in as well. Custom viz. So, we've invested a lot of time in creating these different types of experiments and visuals for each of them. But we also recognize that users may just prefer to have their own custom viz that they want to bring to the table. And so we wanted to make that easier as well. And then lastly, scenario testing. So again, we've invested a lot in different kinds of testing methodologies. And scenario testing is sort of a way to categorize having the complete flexibility over what permutations you want to explore. So for example, you have complete control over different configurations, different model versions, different input sets, and the ability to do repetitions of your experiments. So these are all really exciting capabilities that we've been working on as a result of the product feedback that we got from AMPL on how to integrate these technologies. And so I'm going to show you a brief preview of our pre-release features. All right. So I am in the Nextmv console, and you can see I'm in the Nextmv farm share account. And so you can see all of these different apps that we have for farm share models. I will dive into this first one, which is the facility location model. And so you can see that I've subscribed to that marketplace app that Philippe showed at the beginning of the call. I saw there was a question about having a no-code solution. And so all I had to do to get this application was to clone the marketplace app, and I have that code. And so what I'd like to show is creating an input set. So I'm going to navigate into experiments, input sets, and I'm going to click on new input set. And so this is the default view that a user would see when they go in to create a new input set. You can give it a name, an ID, and you can select from different creation types. Maybe you want to upload your own files or select from prior runs. What I'd like to show you is this pre-release feature of adding an embedded Streamlit application on this page. And so what you can see here is it's loading a new custom view for creating an input set. And so this should look familiar. It's just a modification on the exact same Streamlit app that Philippe showed, where you can select from different cities for the facilities, select different cities for the customers. Everything shows up in the map, just as he showed earlier. You can interact with each of these different variables. You can edit things like facility capacity and customer demand, and you can pick the number of scenarios to generate. And so what I'm going to do is create this input set. And so now what this is doing is it's exporting or creating this input set on the Nextmv platform. And we can see that it just did that, created 6 inputs. So let's make sure it worked. So we'll click into input sets, and you can see that we have 7 seconds ago created this input set with 6 scenario files in it. So now what we'd like to do is show you how you can do scenario testing the way Philippe showed on the Nextmv platform. So I'm going to click into batch experiments, and I will create a new scenario test. And we can call this my scenario test and give it a description if you'd like, and you can characterize the scenario. So I'll call this a varying demand. And now I can select from that input set that I just created. I can select the latest version of the Marketplace app to run on, and I can do things like specify config here, like let's call it 10 seconds. I can specify the solver to be highs. I can also add additional scenarios with different input sets, different versions of the app, and different config. I can also change, for example, if the underlying model is stochastic, we can add repetitions to those scenarios. So in the interest of time, I'm not going to run this right now, but I will go to a previous run that I've made. And so you can see here, this is what the result looks like for a scenario test. And so you can see this is our default view where we present the different metrics and box plots for each of them. And so what I'd also like to show here is that same pre-release feature on this page where we load a custom Streamlit application to view these results instead of relying on the default Nextmv results. And so you can see this is running some analysis. And in a moment, we'll see a similar view to what Philippe showed earlier, where we show the probability of selection for each of these facility locations across the different scenarios. And so in this case, we have basically 100% of the scenarios selected Albany and Pracel to build our new distribution center. So those are some good options for cities that we should think about building and expanding in for our farm share. All right. So takeaways from this presentation. Optimization projects are accelerated by good collaboration, especially across teams. And collaboration can be improved through useful UIs and consoles that you can build and integrate with using tools like Streamlit. And these UIs increase accessibility and understanding of the models and the underlying decisions, especially for non-technical users. So with that, I will turn it back over to Haley for some Q&A time.
Excellent. And we've got about 2 minutes before our at least advertised end duration. So I'm going to slip a couple in here. And I think, Philippe, you've already flagged that you're going to answer one of them in the chat or the Q&A. The Streamlit app, was that also written by ChatGPT?
Yeah, that is also to answer one question about no-code solutions. Essentially, over 90% of the code in there was written by ChatGPT, and I did the remaining 10%. Not just for that app, but for all the other apps in there.
Loving it. It's efficiency. And I think that the question that was asked about the Python extension was also kindly answered by somebody else in the chat. But if that isn't clear, feel free to resurface it. There's another question that somebody has asked around for creating a new model. How are you? What are ways to develop the UI? And if I'm interpreting that question correctly, that might be creating like a net new custom model and how you're applying the Streamlit UI to it.
Yeah, I can start, and Philippe, if you want to expand. Basically, what Philippe showed is a UI for constructing inputs to the model. So I think you could start by defining the schema of your model, and then you can create an app around that to generate that schema. And then in terms of visualizing the results of it, it really depends on kind of what your KPIs are and what you're interested in. So in this situation, it's kind of more of a strategic model, right? Where you're answering the question of where should I build a facility? Other models are more operational. Maybe, for example, a scheduling model, you might have actual names of people and when they're scheduled to work. Or a routing model, you might have a map view showing the routes. So it kind of depends on sort of what you're interested in getting out of those results and how you know whether it's a good result or not. Not sure if that answered the question or if Philippe, you wanted to expand on it.
Yeah, I think that answer. There are many places where this type of UIs can be used, and there are also different types of problems that have different applications. In this case, it's more for providing something for decision makers. In some cases, it might just be to show solutions to people already operating in a factory, just so they know what is the plan for the day. There might also be dashboards for looking at evolution over time, looking at statistics. How are we doing? We are solving optimization problems every day. There are lots and lots of places for integrating Streamlit and maybe also other UI tools so that people can interact with optimization problems more effectively. So that is not just something that ends up in someone else's computer and that is communicated by email.
Because we all need more emails in our lives. Excellent. Well, we are just crossing time, and there's a couple of questions that I know folks have dropped in. I'm going to make sure that we reach out to the folks that we didn't get a chance to surface these questions live today. We'll make sure to send you a message on the side and follow up. The recording for today's presentation will be available online. Again, that is an email everybody will get hopefully in a couple hours here. There's a couple of places that you can go to learn more. I know that there were some really good comments about the AMPL docs. So there's the AMPL site, the Streamlit site, and the Nextmv site that folks can come and visit to learn more. If people have questions afterwards, don't hesitate to reach out. Again, you'll be hearing from us after today's presentation. So Nicole, Philippe, and everybody else that was involved, ChatGPT or human otherwise. Thank you for today's presentation, and we'll see everybody next time.
Thank you.
Thank you.